Okay, good day, Gretchen. Now we're looking at question 4 of November 2018. November 2018. Now we are going to look at we are looking at a table here which have got elements from P, Q, R. They are not specified, and we're given number of protons, we're given number of neutrons, we're given what you call a number of electrons. But before I go on there, we must understand what you call all right. Now the first question is saying define the term atomic number. Atomic number, these are number of what? Number of protons. Number of protons. But we know that the protons plus neutrons must give us what we call atomic mass. Atomic mass. This atomic mass we can be written as a mass number or a nucleon. Please, you must always understand this. This is what you call proton plus neutrons. These are on your atom. Remember, we have got protons and neutrons in the what you call in the center of the nucleus. Then we have got electrons outside on the on the outside shell. So this one is our nucleus, and in our nucleus that's give us our mass. Whatever is inside there, which is your protons and neutrons, give the mass of the atom. You must remember that. So this one is answered. Now let's move on to write down the chemical symbol of element Q using the notation XA over Z. A over Z. Now your A, we know that that's your atomic mass. So here, when we check the and Z, that's your atomic number. But now when you check, you look on the what you call Q, the number of protons is 14. Then you come to your what is it, to your periodic table, you check there, you've got number of electrons, equal to number of protons here, you have got what, 14 there, and that becomes your silicon there. So it is your silicon, so it's silicon. And we are saying when we add atomic mass at protons plus neutrons, we're going to say 16 plus 14, we get 30. Then we're going to say, all right, what about here? We're going to just put 14 there. But remember here, when you check on the periodic table, there is 28 here. Silicon, there is 28. And you must remember, you must understand the concept of what you call the isotopes and X-ray, isn't it? That it's still 14 here, but you can have 28 here. So this is what we want here, the first one there. Now, then we move on to the element PQ. We write down element PQR, that is alkali metal. Alkali metal, what do we know? These are group 1. Group 1. So group 1 in this case, which one is group 1? We come here again, number of protons, number of electrons, we have them 11, and this is your sodium. So sodium in this case is your P. So your answer is P. So this is your answer. Then the chemical symbol of R. Your R, you've got 16 protons, 16 protons, because here 16 neutrons as well. But now we have got 18 electrons. You must always remember the protons, they have nothing. You can't lose protons or gain electrons. That's why I always focus on the protons first, because the protons will give you the natural, what you call, how it exists in nature now. Now, here in this case, like on the periodic table, not in nature, but on the periodic table. So here, this number of electrons, remember, it's biased. Why? Because electrons can be gained, can be lost. So in this case, we'll come and look for R for 16. Which one have got 16 electron? Here we find that is sulfur. Sulfur here. Now, but now the sulfur that we have here, you have got 18 electrons. Meaning to say the sulfur you have gained how many electrons? 2 electrons, because there is an addition of 2 electrons. 2 negative. So that becomes your chemical symbol. Now, let's move on. Element P reacts with oxygen to form the compound with the chemical formula P2O. Okay, predicting the chemical formula that element RB will what call in the periodic table will form. when it reacts with what we call with oxygen. It's in group one, same group as what we call as sodium that we find as P. So it means that it's gonna be formula is gonna be equals to RbO Rb2O, like that. I don't know if it's clear. Rb2, just write it nicely. Rb2O. So this becomes our answer. Okay. Now explain the answer because they're in the same group. Same Rb, same group with the P. Okay, because they are giving the same formula here. Now write what is the trend in ionization energy as you move from element P to element R. From element P to element R. Here's the thing here. Remember what I if you what call pay attention, if you attended a periodic table lecture, you find that number of protons here are increasing and our nuclear charge is increasing. When it's increasing, what happens to it? It attracts electrons more tightly. So it means that the energy required to remove the electrons there will actually be more, will increase. So in that case there we are saying the what called ionization energy increases. But now we need to know what is the reason, because atomic radius is decreasing. My handwriting, my apologies, is decreasing. Now, atomic radius decreases because you're increasing proton numbers. Why increasing nuclear charge? Attract electrons. Tightly. So it attracts electrons, your electrons tightly on the what you call to the nucleus. So therefore, more energy is needed to remove electrons. That's what we're having here. Now, how many electrons does an ion of P of what is it, of element P have? Draw the alphabet diagram. So in this case here, we'll have 11 electrons. If it is an ion now, we know that it's a metal now, it's in group 1. What happens to it? It loses electron. So it's going to be 10 electrons. So 10 electrons. Now, our alphabet diagram, we know that it's a stable now. So we've got 1s, then 1s, then you move on to the what? The 2s orbital. Now, then you move on to the what? To the P, to make them 10. So this is our diagram. So here, this is the 2p. Now when orbitals of identical energy are available, electrons are placed in individual orbitals before they are paired. To give a name of this is Hens rule. Hens rule, saying that electrons, like in this p orbital, you find that when you're placing them, you first fill one, you first fill each of them. That's what the Hens rule saying. Okay, so we must understand this is the Hens rule. That's our answer needed. This is our answer needed as well. Now, element Y occurs as these isotopes of what called in the following proportions: Y 28%, Y 28, 92%, then the 29 is 4%. This one is actually 13%, 3%. Now calculate the relative atomic mass. The relative atomic mass, we know that is gonna be equals to 28. I'm just gonna write the formula for you here. 28 times 92,23 plus 29 times 4,68 plus 30 times 3,09 all over 100. This gives you your atomic mass. Okay, I hope you guys understand. Until next time, thank you.